story about fossils in Calaveras County. So I popped it into your feed so you can peruse it later, but I just want to show it to you because it's so stinking cool and right next door. So mastodons in Calaveras County, what the heck? So if you've ever been to Southern California, some of you maybe, I have assumed, there is a place called La Brea Tar Pits, right in the middle of, like, on Van Nuys Boulevard in downtown LA. It's crazy. It's in there's a Natural History Museum, and then La Brea Tar Pits. There used to be saber-toothed tigers here. Yeah, I'll show you. Funny you should ask. So lots of critters down there. There's lots of natural oil seepage, which is why they have oil rigs off the shore in Southern California and also on land. And like when I was in high school, we used to go to Goleta, which is right by UCSB, for our beach. We'd go over the pass from Solvang, San Ynez Valley, into the Santa Barbara area. And anyhow, La Brea Tar Pits is literally, there's like oozing lakes of oil that animals used to get trapped in. And then the saber-toothed tigers would come and try and eat the animals that were trapped in oil, and then they get trapped themselves. Anyhow, it's a very cool place, and it's still growing. However, this isn't about that. This is about the Mokelumne River, which runs through Calaveras County, which, like Tuolumne River, getting dammed up for Hetch Hetchy and Merced River for water. As you know, the water in the Sierra Nevadas was auctioned off decades ago, almost a century ago, just about everywhere for the people in the population centers, which are away from us. So that's why we have Hetch Hetchy. Well, they have Comanche and Pardee reservoirs because on most winters, there's snow in the Sierras that melts and runs off. Used to be able to run off and flood the whole of the Central Valley. It used to be a big lake, internal lake, and then after that busted out and wasn't a lake anymore, there's still the Delta region, which has now been built up and purposefully reinforced to keep flooding from happening. Anyhow, you know, we have water and other people get our water. So the water from Calaveras County ends up in Pardee and Comanche reservoirs. And some of you may have been to those before because they're good fishing holes and stuff. And everybody likes to go to lakes for recreation, right? So Mokelumne River comes down out and goes here. And then it passes out of Comanche and on its way towards Lodi and Stockton and all that. So why am I bringing this up? Well, a gentleman that works for East Bay Municipal Water District or Utilities District stumbled across a naturalist. They have naturalists that have to, you know, keep tabs on things and make sure that the system isn't causing problems, etc. Turns out he stumbled upon something, this gentleman right here, in the summer of 2020, last summer. While everybody else was hunkered down in their houses, he was out hiking trails.
The discovery occurred while I was on patrol out on the watershed, and I happened upon a petrified tree. This tree was partially encased in the burial sediments, and because one end was exposed, I could actually see the tree rings inside. So I looked around the area further, and I discovered a second tree, and then a third, and so on. After finding dozens of trees, I began to realize that what I was looking at was the petrified remains of a forest.
So this is a little model mastodon. So they look like elephants, only with extra long tusks. And I have a little tiny piece of petrified wood that I picked up at a rock show somewhere along the way. And you can tell it has the pattern of wood grain and stuff. You can see the rings also. And I'll set it here if you want to look at it later. It's been polished and coated, but it's a rock. It's not wood anymore. And so this guy who was trained, you know, you have to kind of know what you're looking at. Like you look at something like that, average person would just walk over it and not think anything. But you can kind of see that there's lines here. And there we go. And lines down here and stuff. And those are like the grain of wood. So you've seen a table before, I'm sure, or wooden floor or whatever, and you've seen those lines. Well, you can see them in the rock. And what ends up happening is when I'm assuming that this is because it was flooded because of all the runoff from the mountains and stuff. But if that forest gets flooded and then silt builds up and minerals are in there, they get incorporated into all the cracks and crevices. And after millions of years, incomprehensible amounts of time, most people have a hard time thinking about 100 years or 200 years, right? The sediment gets in there and incorporated and lithifies, forms of rock. And so he was walking around noticing that was happening. So like this thing, I wouldn't think that that's a tree, but apparently that's a I'm not even sure which one is the tree. I think it's this one. So, you know, how geologists put things into pictures so you get a size perspective. That's his little walkie-talkie. This is a little more obvious rock hammer, and you can, I mean, that looks like a log, right? I mean, at least it does to me, but it's rock. It's not wooden. And this is a bone. Have you ever seen old dried up bones, like out on a hike or something? They have the porosity in the bones. That's for where all the blood supply and nerves and things like that, blood supply goes through, because bones alive, right? Your bone marrow and stuff, it's living, it's constantly evolving and changing. It's not static. Once you have your bones, they're constantly remaking all the time. And so obviously that's a pocket knife to give you perspective. They don't know what kind of bone that was, at least at this time. But all these critters in this picture, they found fossils from these critters. And he reached out to some people at Cal State Chico. I'm guessing maybe he's a Chico grad. I don't know, but why he picked Chico instead of, like, UC Santa Cruz has a big earth science, earth environmental science. That's where my son is looking at this kind of stuff. Anyway, they've recovered the mastodon, a Gomphorthery, whatever the heck that is. It's really crazy. It's like a mastodon, except it has not just two tusks, it has tusks out of the bottom jaw too. So it has four. Birds, fish, tortoise, tapir, and other things. So this woman is looking at a fossilized fish. So to get a fish fossilized, they have bony backbones and stuff, but it's still really hard to get fish, you know, to lay flat long enough to fossilize. But again, these rivers had lots of salmon going up them. This is a bone. Oh, let me go back. Tapirs are really cute. You guys know what a tapir looks like? They're super cute. So that's a baby tapir in Dublin. So anyway, it's an ancient critter. It's been around a long time. This is a jaw from an ancient tapir, which was much bigger than modern ones. And they actually did a 3D scan. You know, if you've ever been in for your braces or whatever to get a 3D scan of your jaw, they did that on this tapir jaw. Kind of crazy. And then, wait till you see that. Oh my gosh, that's a tooth. He's holding a tooth. So let's show you what the heck is that from. That is from this. So there's a mastodon, to answer your question. Looks like a giant elephant, except with a really long tusk. And those, it's like an elephant. So they have these crazy molars that have like jagged edges. It's not just like jagged on the outside. It's like really for grinding up lots of vegetation, big flat chewing surfaces. This is a tooth and a part of the tusk that they're working on deciphering. They found an entire mastodon skull with tusks in Calaveras County on the Mokelumne River. Get out. So when they collect fossils, they wrap them up like you would get a plaster cast for your broken arm or something. They wrap up the fossils and lots of stuff and then put a plaster cast around it to transport it. And here they are at Chico cleaning it up. You can see they sawed through it. That's unfortunate, but I guess they had to get it to movable size. And then there's the tooth I just showed you. They found a toe bone from a camel species. They've got teeth from ancient horses. There's a lot of argumentation about whether this is actually the evolutionary pattern for horses. That's kind of my thing too. So anyway, rhinoceros in Calaveras County. How is that possible? But apparently there was. This gentleman's digging up a tortoise shell. So this down here is the base plate, the stomach plate of an ancient tortoise that they found on this plane. And then this is the Gomfer, whatever the heck it is, welded beast. This guy right here with 4 tusks, big long ones and 2 out the front. This is the jaw coming out and then getting hauled into the truck to haul it away. So they haven't released the exact location, obviously, because they don't want everybody running out to it and disturbing things and messing up the other fossils. But they have found fossils here before. This gentleman in the 40s found a mastodon jawbone when he was inspecting or putting in the pipeline that runs out to the East Bay. And they dug them up and wrapped them up and sent them off to a Contra Costa. I'm not sure why, but I mean, that's in the East Bay. So, you know, it's not like it was a total surprise, but, you know, 70 years ago, most people have forgotten about all that stuff. So anyway, it was surprising for the biologists this time. So McCalmey River, the Milk River, is a part of the Wild and Scenic Rivers protection, and Chico State's doing a lot of the cleaning up. So I don't know if anybody's interested in going to Chico State. My niece got her BS in nursing there, but I didn't know they had a big geology department. So these are the geologists from Chico. Anyhow, pretty dang cool. If you're interested in fossils and rocks, who knows what you'll find in our area. It's kind of crazy. So I wanted to share that because it's science, baby, even though it's not physics, baby. And I know you want to get to wave machines and gummy bears. Heck yeah. So we have, let's see, 11:07. We have, I want to do 5 minutes of notes. Okay, so those of you in the room, I have a copy for you. Those of you at home, I will get to. All right, so let me give you this. Last Monday. You guys excited or what?
Yeah. That's a yes and no. That's a yes and no answer.
That's a yes and no.
Finals? No. I'm not excited.
So this is yet another example of someone's gummy bear. I guess he's British, and I guess they have bigger gummy bears over there. Our wave machines won't be this long, and I don't want to play this because he talks about expected results, but maybe tomorrow we'll look at it. All right, I just want to talk about a few things with waves. So it's all great and fine to know about waves and periods and frequencies and wavelengths and amplitude and nodes and all that. But what's cool is what happens when waves encounter each other. There is something called interference that happens when 2 or more waves go in the same place. And it's a really weird concept because we think of waves as being made of matter, but they're not. They are energy. Okay, so energy moving through matter and or through space. So they can interfere with each other and be in the same place at the same time, which is kind of strange. The superposition principle says that there's something going to happen, and it depends on how the waves come at each other, and I'll try and show you that here in just a second. But as they move through the medium, whatever medium they're moving through, there is an actual mathematical way we can describe their displacement. And that's past the scope of what we have time for, obviously, but it is, excuse me, I think I'm getting sick too on top of everything else this weekend. Okay, so, and it's probably just better just to show you a video, but let me just show you these pictures real quick. So if we have a big wave and a little wave coming at each other, what would you predict what might happen?
The
Okay, so you would expect that because of little carts, right? So with constructive interference, the waves combine so that the momentary resulting wave is bigger than either of them. They actually add together. It's really strange. And so your little wave and your big wave overlap and add up, and then they go on their merry ways in the same direction they were going to start with. I know. All right, so that's constructive. When things construct, they get bigger, okay? And they pass through each other. It doesn't seem possible, but they do because they're energy. All right, if you have two waves like this, you will have what's called destructive interference, which you might expect is making them smaller. So they overlap and pass through, and they kind of cancel each other out. So there are sound canceling headphones out there. Some of you might have them. And how does that work? The little electronic devices reads the sound waves coming at it and matches it with something to destroy that sound wave, to break it up. For example, this is a rope, but the same kind of thing can happen with sound waves. Okay. And again, once they're past being together, they just go off the same as they were to start with, going in the same direction they were going to start with. And it is definitely counterintuitive. So that's a 5-minute video. All right, let's just try this. I'll skip this for right now. We'll look at it tomorrow. Okay, number one, what's going to happen? Constructive. What about number two? Number three? Yep, good job. You guys got it. So water also shows waves in phase and out of phase. That's another way that we talk about it. So if they're out of phase, the crest of one is the trough of another. That's like destructive. If they're in phase, the crest of one and the crest of the other go together, like constructive. So there's different terminology that's also used. It could be both troughs, right? Extra low if they're in phase, canceled if they're out of phase, a trough and a crest. And a classic device for looking at wave interference in water is called a ripple tank. We have one, but the motor doesn't work. But I remember in high school physics a long time ago, being amazed at the ripple tanks. So these are little motors that have little metal hooks that just kind of go ding, 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 ding. And so like if you just make one mark, it sends out a ripple of waves. Well, when those waves encounter each other, depending on where they are, they will interfere with each other, and it can be in phase or out of phase. It can be constructive or destructive. And so you get this, the black area, I believe, is supposed to be the destructive area, and the light area is the constructive. But there's a distinct pattern where waves interact. And this is what is actually, something like this was actually used by Thomas Young to prove that light, electromagnetic radiation, is a wave. He did something called the double slit experiment, and we'll hopefully talk about that super briefly on Friday. But wave is light is a particle, so we proved that by doing the photoelectric effect and knocking electrons off eons ago. And then they said, no, it's a wave, and Thomas Young proved that. So it's both. Light, little bundles of energy traveling as photons, is both a wave and a particle. And this pattern from physical waves in water is also seen with light, and it's kind of cool. All right, we're going to stop right there. I said 5 minutes. I went a tad longer. I apologize. Questions right now? Okay. So we are going to today talk about putting our gummy bears together. Those of you that are in the classroom, go ahead and you don't need to be on the meeting any longer. Those of you at home, hang on for just a minute more. Got the Mastodon, got that, got this. All right. So all of you have chosen, people at home, you still haven't told me, except for Raquel, what you want to do. Jasmine's with her team. So what we're going to do today is put the candies on the skewers and then get another piece of tape if you want to go over the top. That's not a requirement. It should still work. But the task today is to get everything set up, get all the skewers with candy and get them in the proper placement, get them balanced, and see if we can get them set up for today. Does that sound good? All right. So that's what we're doing today. We're not actually taking any measurements yet. As far as data collection, we'll do that tomorrow. So yeah, those of you at home, I want to just, I meant to say something about the final. So we already had that. We had that. We had that. I think I'm just going to focus on what we've done for the last couple of weeks on waves. We did that. No fluids. I think it's chapter 11. That's what we're in. Did we do stuff in chapter 10 too? Oh, yeah. Yeah. So heat was in chapter 9, a little tiny bit of chapter 10, the calorimetry stuff. We haven't tested on that. And then the stuff on waves and a little bit of sound on Thursday and a little bit of light on Friday, assuming you're all here on Friday. Okay. Anybody else? Questions? You can make a full sheet of handwritten notes, front and back, whatever you want, whatever you think you need. Obviously, a calculator would be good to do the calorimetry calculations. And then there'll be some calculations on wave speed stuff, wavelength and frequency stuff, which we'll do probably Wednesday for your asynchronous. All right, any questions right now? Bloop. What do we have to tell you? I was testing this. Oh, thank you, Nancy. So which of the four are you interested in? How does wave speed change if you change the medium? How does wave speed change if you change the amplitude, change the frequency? Nobody picked, oh no, we did get someone to change. So medium, amplitude, frequency, or length of skewers. So which one of these four would you like data for? Amplitude, okay. Beautiful. All right. So we're good with that. Anybody? All right. Once you get with your teams, those of you that are in the room,